Welcome to the Duck Dive. Today we're tackling artificial general intelligence, or AGI.
Right.
Forget your everyday AI that handles one specific thing. We're talking about systems that can learn and think, like humans across the board.
And even looking beyond that to artificial superintelligence, ASI, where machines could potentially, outthink us. It's quite the leap.
It really is. And to get a handle on where things stand, you've brought us a really interesting recent study.
I have. It's called Navigating Artificial General Intelligence Development: Societal, Technological, Ethical, and Brain-Inspired Pathways. Just published last month, March 11, 2025, actually, in Scientific Reports.
Okay, by Raghu Raman and several other researchers.
That's right. Robin Kowalski, Krishna Sriyachuthan, Akshay Iyer, and Prima Nedungadi.
Great. And for our listeners, who want to get up to speed on complex topics quickly, but thoroughly, our mission here is really to pull out the key insights from this paper.
Exactly. Give you that shortcut to understanding the AGI landscape without getting totally bogged down.
So this study maps out the different routes, the pathways for AGI development, and the challenges.
Precisely. It identifies the major hurdles, future directions. They used the Prisma framework for the review and something called BERTopic modeling.
Okay.
Yeah, basically to sift through tons of research and pinpoint the core themes. They've done the legwork for us, really.
Fantastic. All right, let's dive into the first pathway they flagged. Societal integration. What's the essence of that?
So at its heart, societal integration is all about how AGI fits into our lives. Public acceptance, regulations, policies, and specifically how human-like attributes play a role.
Human-like attributes. Okay, that makes me think of CASA theory in service AI. What did the study say there?
Right. CASA computers are social actors. It's this idea that we tend to interact with computers socially. And in service AI, the study highlights that the quality of the interaction, how much we feel the AI gets us, it's perceived empathy. That can actually be more important for building trust than just making it look human.
So it's less about the avatar and more about feeling understood and, effectively engaged.
Exactly. The interaction quality is key for acceptance.
And the study also mentioned our comfort level with these human-like traits isn't fixed. It can change.
Precisely. It seems to depend on how much control we feel we have in the situation.
How so?
Well, the researchers found that in high-control situations, we actually prefer AI that shows human-like empathy and decision-making. It feels more natural, maybe.
Okay, that makes sense. But if we feel less in control...
That's where it flips. In low-control scenarios, that same highly human-like AGI can make people feel uneasy, apprehensive even.
Like it raises questions about who's really in charge.
Kind of. Maybe a bit of that uncanny valley feeling, but tied to control.
Interesting. So looking bigger picture, the study mentioned the PESTEL framework. How does that help understand the societal angle?
Political, economic, social, technological, environmental, legal. It's a way to get that bird's eye view.
Right.
The researchers used it to map out potential societal consequences. Geopolitical trends tied to superintelligence, robotics. The big takeaway is the need for governments, organizations to really anticipate these shifts.
Like employment changes, ethical stuff.
Exactly. Employment, ethical rules, governance. They need to be thinking about this proactively, not reactively.
Okay, that gives us a good sense of the societal pathway. Let's switch gears now to the tech itself, the technological pathways. What advancements did they focus on?
Yeah, this part looks at the actual, evolution and integration of AGI tech, how it connects to real-world uses and challenges.
And one thing mentioned early on was deep reinforcement learning, DRL, for autonomous driving. Why is that seen as a step towards AGI?
Well, the big deal with DRL is the learning method. It's a shift away from just supervised learning, where you feed it labeled data. DRL lets the system learn through basically trial and error in a dynamic environment. Imagine a car learning to drive by actually driving and adapting, not just following pre-programmed rules for every scenario.
So it's learning from experience, more like we do.
Exactly. That ability to adapt through interaction is considered pretty crucial for more general intelligence.
Okay. Now, what about the models everyone's talking about, LLMs, like ChatGPT? How do they fit in?
Oh, LLMs are definitely a huge part of the story. Their rapid progress has really accelerated the whole AGI discussion, hasn't it?
For sure.
The study points to their potential impact on jobs, creativity, human-machine interaction. They even mentioned how people were categorizing ChatGPT's abilities early on, like creative writing or generating code.
That versatility is key then.
It really is. It hints at where AGI might be heading.
It's incredible how fast they've developed. But the study also brought up Project Malmo in Minecraft.
Yeah.
That sounds a bit, well, different.
Yeah, it might sound like just a game, but Project Mallow is actually a really smart AI research platform.
How does it work?
It uses Minecraft's complex simulated world as a kind of testing ground. AI agents can learn to solve diverse problems, they can collaborate, adapt.
A virtual sandbox for AGI.
Pretty much. It lets researchers test learning algorithms and decision-making in an environment that has some of the messiness of the real world, pushing towards that general problem-solving ability.
Okay, makes sense. So we've got societal and technological paths. A really critical piece, though, is understanding how these systems make decisions. The study called this pathways to explainability. Why is that so important?
Explainability is absolutely fundamental. I mean, as AGI gets more powerful and involved in critical decisions, think healthcare, finance.
Right.
We have to be able to understand why it does what it does.
Yeah.
It's about trust, finding errors, making it safer, more useful. That lack of transparency now, it's a major roadblock.
So how do we bridge that transparency gap? What's happening with explainable AI or XAI?
The researchers stress needing XAI that doesn't just say what decision was made, but why, ideally in real time.
The reasoning behind it.
Exactly. So advancements are focused on providing those causal explanations, linking the why back to the AI's learning process. It helps us understand the present and maybe even predict future actions.
The study also mentioned reinforcement learning again, linking reward maximization to behavior. How does that connect to explainability?
Well, the idea is that in RL, the AI learns by maximizing a reward signal. If we understand the reward it's chasing and how it's optimizing for it.
We can figure out its motivation.
Sort of, yeah. We get insight into its strategies, its priorities. The study suggests this reward-driven generalization is a promising route both for achieving AGI and for understanding its decision-making logic.
But even with these methods, reaching human-level AI seems really tough. The studies talked about the brittleness of current systems. What does that look like practically?
Brittleness basically means that AI can be amazing at specific tasks it was trained on, but it falls apart or acts weirdly when faced with something even slightly different. It lacks our common sense or adaptability.
Like it can identify dog breeds but can't follow a simple instruction.
Exactly that kind of thing. The study notes that even advanced systems struggle with everyday common sense reasoning. Overcoming this brittleness is a massive challenge for true AGI.
Makes perfect sense. Okay, the next pathway. Cognitive pathways and ethics in AGI. This sounds like it gets into deeper questions about intelligence itself.
It definitely does. This pathway links the AGI's underlying architecture, its cognitive setup with ethics, responsibility, societal impact. The focus is on enabling AGI to reason and decide in ways that align with, well, human values.
And they mentioned the LIDA cognitive model. What's that about?
LIDA Learning Intelligent Distribution Agent. It's a model inspired by global workspace theory, which is one idea about how human consciousness works.
Okay.
The study sees LIDA as a potential blueprint for building essentially moral reasoning into AGI. It tries to simulate human attention, learning, memory, including both emotional and rational processes.
So trying to mimic how we make ethical choices.
That's the goal. By copying those mechanisms, the hope is that AGI can learn to make context-aware, ethically sound decisions, especially in tricky situations.
Like building an artificial moral compass.
That's a decent way to put it. Giving it a framework that mirrors how humans weigh different factors, including ethical ones. The study really emphasizes this is crucial for trust and accountability.
What about AI completeness and the Turing test? How does that fit the cognitive angle?
Well, the idea of AI completeness, using benchmarks like the Turing test, is about setting clear goals for achieving general intelligence.
Right. Can it fool a human into thinking it's human?
Exactly. Passing it implies a certain level of human-like cognition, common sense reasoning. Formalizing these benchmarks helps track progress and identify what truly requires human-level thinking. And that, of course, has big implications for industry.
And then brain-inspired neurocomputers were mentioned. How do they connect here?
They represent a different approach. Instead of just programming intelligence, this imitationalism focuses on mimicking the brain's structure at the hardware level.
Neuromorphic computing.
Right. The idea is if you build something that functions like a brain, maybe you get autonomous learning and interaction emerging from that. It also raises, some pretty deep questions about how close AGI should be to biological intelligence.
Which leads us perfectly into the fifth pathway. Brain-inspired systems. We touched on neurocomputers, but what else is happening there?
Yeah, this path is all about that intersection of neuroscience and AI. Studying the brain, how it learns, adapts, reasons, and applying those principles.
So neural networks, specific computing architectures.
And cognitive architectures directly influenced by brain structure and function. The aim is always better learning efficiency, adaptability, stronger reasoning for AGI.
The study called out the Tianjin chip specifically. What makes it a significant hybrid platform?
The Tianjin chip is cool because it integrates two different approaches on one chip. Brain-inspired spiking neural networks, SNN.
Which mimic neuron firing.
Right, potentially more energy efficient and good for time-based data. And it combines those with traditional artificial neural networks, ANNs.
So, the best of both worlds.
That's the hope. More efficient processing, real-time adaptation, lower energy use, all critical for AGI. Its ability to handle different kinds of tasks at once was a big step.
Interesting. And neuroevolution, how does that use brain inspiration?
Neuroevolution basically uses evolutionary algorithms, think natural selection, to optimize neural network designs.
Instead of designing them by hand or just using gradient descent.
Exactly. It lets the architectures kind of evolve. It can be really useful for meta-learning, learning how to learn, and finding novel network structures. It's another way of tapping into the principles that created biological intelligence.
Finally, under this pathway, they mention the unreasonable effectiveness of deep learning. What's the connection to brain-inspired AGI's future?
Right. That phrase refers to how surprisingly well deep learning works, even if we don't fully grasp why sometimes. The study links its success to things like high-dimensional geometry optimization methods. While it's not a perfect brain mimic, its pattern-finding ability has driven huge AI progress.
So what's the future prediction?
The researchers suggest future brain-inspired breakthroughs might come from looking beyond just the cerebral cortex, maybe exploring brain regions involved in more basic survival functions. Could yield new insights for more robust AI.
Okay, so we've walked through the 5 key pathways from the study. Stepping back, what did the researchers identify as the really big overarching challenges cutting across all these areas?
Yeah, the study synthesizes these obstacles really well. They cover a huge range: technical, theoretical, ethical, legal, social, psychological, economic. It's a lot.
Let's touch on the main ones. Technical hurdles.
Big ones include the need for AGI that can learn continuously. Lifelong learning, essentially. Adapting, applying knowledge across domains.
And resource management.
Definitely. Managing the immense compute power and energy needed is a major technical problem. Plus, ensuring robustness and generalization, making sure AGI works reliably even with unexpected inputs.
What about the theoretical challenges? Big unanswered questions.
We're still figuring out the fundamental complexities of information processing, especially in messy, real-world environments. And the study stresses incorporating embodied cognition.
Giving AI a physical presence or understanding.
Right. Understanding the world through interaction, like we do.
Yeah.
That scene is key for more complete context-aware intelligence.
And the ethical, legal, social side, we've touched on it, but what are the core challenges there?
Oh, huge challenges. Responsible development frameworks, effective governance, figuring out liability when AGI makes mistakes, data security, privacy, and the broader impact on things like democratic values and equality. It's a minefield.
Then there are the psychological, societal, economic challenges.
Yeah, the study points to potential shifts in human AI populations, how that might disrupt social order, the risks of rapid, maybe uncontrolled advancement, and of course the profound impacts on jobs and resource management across the economy.
It really highlights the sheer complexity. Now, what about the implications the study draws from all this? Starting with the theoretical side, how does this push our understanding forward?
Theoretically, it really reinforces several needs. We need better XAI frameworks to actually understand AGI decisions. We need to expand cognitive architectures with that embodied cognition piece. It also champions reinforcement learning and neuroevolution as key methods. And it suggests exploring collective intelligence ideas and refining our basic theories about human-like AI and even consciousness.
Okay. And for the people actually building this stuff, the practitioners, what are the practical takeaways?
For them, it's about preparing for workforce integration, thinking about upskilling, retraining. Critically, designing systems that are transparent and trustworthy is non-negotiable for adoption.
And thinking about context.
Yes, ensuring AGI can adapt across different sociocultural settings. And maybe the biggest practical point, the absolute necessity of cross-disciplinary collaboration. No single fields can tackle this alone.
Finally, policy implications. What should governments and regulators be focusing on?
Policymakers have a massive role. The study stresses needing regulatory frameworks now for responsible deployment, making sure benefits are shared fairly.
So promoting inclusive access, ethical governance.
Absolutely. Clear ethical guidelines, robust safety protocols, long-term risk mitigation, that has to be a priority. And also incentivizing AGI applications that actually help with global goals like sustainability.
It's a huge agenda. Now, the study itself, like any research, had limitations. What did the authors acknowledge?
Yeah, they were upfront about that. They mainly used the Scopus database, so some research might have been missed.
Okay.
For topic modeling, the analysis method has its own constraints in how it groups topics. And, relying on citation counts as a measure of impact always has potential biases.
Fair enough. But despite those, they did identify some interesting themes emerging in AGI research, prevailing, rising, and novel ones.
They did. Prevailing themes show that strong focus continues on ethical guidelines, governance, and also AGI in healthcare.
What's rising?
Rising themes include more interest in AGI combined with collective intelligence and a growing focus on those brain-inspired architectures we discussed.
Yeah, novel themes. Things just starting to bubble up.
Novel themes include exploring AGI and consciousness, a really deep area, and the potential for AGI in education.
And they suggested future research for each?
Yeah, things like developing ethical guidelines specifically for sustainability, finding ways to integrate human expertise with AGI for global problems, really pushing hybrid brain-inspired designs, digging into the theory behind introspective AGI, and creating those personalized, adaptive AGI education platforms.
Wow. So this deep dive into this study really gives us a vital map of this incredibly complex journey toward AGI.
It really does.
It shows just how interconnected the tech, the societal impacts, and these fundamental questions about intelligence really are. And for you, our listener, we hope this has clarified those key pathways, the big challenges, and where things might be heading.
Absolutely. It's a journey that definitely requires careful thought and lots of collaboration.
Couldn't agree more. And on that note, here's a final thought for you to chew on. Considering these 5 pathways, societal, technological, explainability, cognitive ethical, and brain-inspired, which one do you think will be the most critical hinge point? Which one will most shape AGI's future and how it fits into our world?
That's a great question to ponder.
Definitely no easy answer, but something we're thinking about as this field continues to rocket forward. Thanks for joining us on The Deep Dive.